Welcome back, friends, for the chapter real numbers of 9th standard, the remaining part. So the topic is the binomial quadratic surd. Binomial quadratic surd. At first, what is meant by binomial? Binomial means two, which has the two terms. Binomial means two term, and quadratic means its order is two. Its order is two, and that is the surd having two terms and the order of that surd is 2, then it is known as the binomial quadratic surd in our words. The actual definition is the sum or difference of two numbers, one of which is quadratic surd and another one is non-zero rational number or a quadratic surd. It is known as a binomial quadratic surd. Means what? It is a sum or subtraction. Sum or difference of two terms. This is the first term, this one is second term. Out of which one is a quadratic surd. One is a quadratic surd. And other one is, it is a non-zero rational number or a quadratic surd also. Means in these two terms, one is quadratic surd and another one is the non-zero rational number, or both the terms are of the quadratic surds. Then this is known as a binomial quadratic surd. If one is a rational non-zero rational number, other is a quadratic surd, there is the addition or subtraction between a non-zero rational number and a quadratic surd. Addition of two quadratic surds or subtraction of two quadratic surds are also known as the binomial expressions. In these, root A, root B, root A, root B are the quadratic surds, and A, B, X and Y are non-zero rational number. The alphabets or the variables which are used here, X, Y, A, B, they may be any non-zero rational numbers. Then such type of expressions are known as the binomial quadratic surds. Some examples of the binomial quadratic surd are 5 plus 3 root 2, 5 minus 3 root 2, 2 root 3 plus 3 root 5, 3 root 2 minus 5 root 3. These are the examples of binomial quadratic surds. Binomial quadratic surds. Then the new term in this topic, that is the conjugate pair. New term is conjugate pair. Conjugate pair. Conjugate pair means the product of two conjugate pair binomial surds is a rational number. If the two binomial surds whose product is the two binomial quadratic surds whose product is a rational number, then they are known as the conjugate pair. Conjugate pair of binomial surds means nothing but they have the same terms, but in between them the one has the positive sign and another one is negative. Means 5 plus 3 root 2 and 5 minus 3 root 2. This is known as a conjugate pair of binomial surd. This is a conjugate pair of binomial surd. Okay? Is it clear? What is the binomial quadratic surd and conjugate pair of binomial surd? Okay? Now come to the next topic, that is the practice set 2.4. First question is simplify. Simplify means we have to perform the given processes. First example, root 3 into bracket root 7 minus root 3. Means we have to multiply this by root 3 to both the terms and then perform the subtraction. Okay. Root 3 into root 7 is, they have the same order, that is 2. So they are taken under the same radical sign, that is under root 3 into 7 minus root 3 into root 3. First of all, we multiply root 3 by root 7 and then root 3 by root 3. 3 7 is 21. Root 3 into root 3, that is 3. Okay, so our answer is like this, root 21 minus 3. Now the second example is the same, but only the multiplying term is given after the bracket. So same process is there, root 5 into root 2 minus root 7 into root 2. The order of the surds are same, that is 2. Hence 5 and 2 are taken under the same radical sign, as well as 7 and 2 also taken. 5 to the 10 minus 14, 7 to the 14. Root 10 minus root 14. This is the our answer. Okay. Now we take the third example of this question, that is 3 root 2 minus root 3 into another bracket 4 root 3 minus root 2 bracket complete. Means we have to multiply both the brackets, this one and this one. Two brackets are given and each bracket has the two terms. So for this, we have to take any bracket 2 times and then multiply by the remaining bracket. So here we take the second bracket twice, 4 root 3 minus 2 and 4 root 3 minus 2. We have to multiply to this first bracket by the first term of the first bracket, that is 3 root 2, and to the second bracket by this second term minus root 3. 3 root 2 into 4 root 3. 3 into 4 under root 2 into root 3. Minus into plus minus. Now multiply to this second term. So what happened? 3 root 2 into root 2. Now go for the second. Minus into plus minus, 4 root 3 into root 3, and the remaining minus into minus plus, that is root 3 into root 2. Okay. What happened? 3 4s are 12. Under root 2 into 3. 2 3s are 6. Minus 3 1s are 3. Root 2 into root 2, root 4. Minus 4 1s are 4. Root 3 into root 3. Root 9 plus root 3 into root 2, root 6. So what happened? 12 root 6 minus 3 into square root of 4 is 2 minus 4 into square root of 9 is 3 plus root 6. Now equalize the terms. Collect the like terms here. 12 root 6 plus root 6. 12 root 6 plus root 6 minus 3 into 2 minus 6 minus 4 3 the 12. So we take root 6 common here, 12 plus 1 and minus 6 minus 12 minus 18. So what happened? 12 plus 1 13. 12 plus 1 13. Root 6 minus 18. This is our answer. Okay, do you understood this? We have to take the second bracket twice, multiply this bracket by the first term to the first bracket, that is 3 root 2, and to the second bracket we have to multiply by the second term of the first bracket. Root 3 into root 2 into 4 root 3. What happened? 3 into 4, that is 12. Root 2 into root 3, that is root 6. So what happened? Root 3 root 2 into root 2, 3 root 4. 4 root 3 into root 3, 4 root 9. And root 3 into root 2, that is 6. In this way, 12 root 6 minus square root of 4 is 2, square root of 9 is 3, 2 3 is 6, 4 3 is 12, and this root 6 taken here. Root 6 taken common, root 6 taken common, 2 plus 12 plus 1, that is 13, root 6, and minus 6 minus 12, that is minus 18. Now, okay, the second question is rationalize the denominator. Rationalize the denominator. Rationalize means obviously the denominator is irrational and we have to convert it into the rational number. So they rationalize the denominator. Here see the first example, 1 upon root 7 plus root 2. Root 7 plus root 2, obviously this is irrational number. We have to convert this denominator root 7 plus root 2 as a rational. So for this we have studied that the conjugate pair. What is the conjugate pair of 7 root 2? The conjugate of root 7 plus root 2 is root 7 minus root 2. Means we have to multiply and divide by root 7 minus root 2 to this given term, that is root 7 plus root 2 into root 7 minus root 2 divided by root 7 minus root 2. So what happened? See here, 1 into root 7 minus 1 into root 2 root 2. But at denominator what happened? A plus b, a minus b. We know that the identity is a plus b, a minus b, that is a square minus b square. So what happened? Root 7 minus root 2 divided by square of 7, root 7 is 7 and square of root 2 is 2. So what happened? 7 minus 2, root 7 minus root 2 upon 7 minus 2, 5. When we observe this, here the denominator is 5 and 5 is a rational number. Hence we rationalize the denominator. denominator. Okay. Now second example of the question number 2, rationalize the denominator. The example is 3 upon 2 root 5 minus 3 root 2. Obviously the denominator is irrational and it is a binomial quadratic. So we have to multiply by the conjugate of this one. Conjugate of this is 2 root 5 minus 3 root 2, that is obviously we take the plus 2 root 5 plus 3 root 2. 3 upon 2 root 5 minus 3 root 2 as it is, multiply and divide by the conjugate of this. The conjugate of this is this one, 2 root 5 plus 3 root 2. So we have to multiply by and divide by the conjugate. So what happens at the numerator, 3 into 2 root 5 plus 3 root 2 upon. So what happens here? A minus B. A plus B. A minus B into A plus B equals to, we know that, A square minus B square. So A is 2 root 5 square of it, minus B is 3 root 2 square of this, and at numerator 3 into this one, 3 into 2 root 5 plus 3 root 2. So what happened? 3 into 2 root 5 plus 3 root 2 remains as it is. Square of 2 is 4 and square of root 5 is 5. Square of root 5 is 5 minus square of 3. Square of 3, 9 into square of root 2, that is 2. 4 5 are 20 minus 9 2 are 18. 20 minus 18, that is 2, and numerator remains as it is. In this example, the denominator get converted to a rational number. Now the third one example. The third example is root 5 minus root 3 divided by root 5 plus root 3. Obviously the numerator and denominators are conjugate of each other, but we can't consider the numerator at this stage because we are going to rationalize the denominator. So we consider the denominator, root 5 plus root 3. The conjugate of root 5 plus root 3 is root 5 minus root 3. Okay, so we have to multiply and divide by the conjugate, means root 5 minus root 3. The given ratio, root 5 minus root 3 divided by root 5 plus root 3 as it is, and we multiply and divide by root 5 minus root 3 and root 5 minus root 3. So what happened here? Suppose root 5 is considered as A and this is as B. A minus B into A minus B. A minus B into A minus B, that is A minus B whole square. And at denominator, A plus B, A minus B, means A square minus B square. A minus B square, A square minus B square. So this is A and this one is B. So we expand this. A minus B bracket square equals to A square minus 2AB plus B square, and A square means square of root 5 is 5 and square of root 3 is 3. So we expand this. Square of root 5 is 5 minus 2 into root 5 into root 3, root 5 into root 3, that is root 5 into root 3 is root 15. Root 5 into root 3 is 15 plus square of root 3 is 3 divided by 5 minus 3, 2. When we see this, 5 plus 3, 8 minus 2 root 15 divided by 2. We take 2 common at the numerator. When we take 2 common, here 4 is remains, 2 4s are 8. 2 is taken minus root 15 divided by 2. 2 divided by 2, 1, that is 4 minus 15. 4 minus root 15. Denominator is not given, means it is 1, and obviously it is rational. So it is not necessary to write 1 at the denominator. Okay. Today here our practice set 2.4 is over now.